This section of Unit 5 is about similar polygons. By the end of the period, you will be able to determine if two polygons are similar. You will also be able to take two similar polygons and find missing side lengths. Before we get into the lesson today, let's take a look at some of our properties of proportions. We're going to hit a little bit more on this from what we had done last unit. So solve following proportions. What do you notice? What is the same? What is different? So go ahead and solve both of these. Answer those three questions. Go ahead and pause the video because then I'm gonna kind of talk you through what I'm hoping you noticed on here. So what I'm hoping that you see here is that you're gonna solve and get A to be the same for both of these. Okay. Now, again, when you solve a proportion is when you have two ratios set equal. Another way to say that is you have two fractions set equal. Well, how do you solve proportion? Well, you cross multiply. So we took, A times 5 and 10 times 2. What you need to recognize is that as long as when you have two different, because these are two different proportions set up, if you're still multiplying the same numbers, or in this case, a variable and a number, when you cross multiply, it's really going to give you the same answer. So when you're setting up proportions on your own, you have to realize that, and I know we're not in class, but if you were to look at like a neighbor's work and their proportion is set up differently than yours when you're using it to solve, you both could still be right even if you set it up differently. Again, practice from last lesson. Go ahead and solve this word problem. All right, the distance from Vancouver to Edmonton is 1,200 kilometers. How far apart will the two cities be on a map with a scale of 1 centimeter equals 75 kilometers? So go ahead and take this, set it up, solve it. Go ahead and pause the video because then I'll walk you through the answer. Okay, now I put the units on here just to help me remember what I'm trying to find and what information I have. Okay, so it tells you the actual distance between the cities and it tells you the scale factor, 1 centimeter is 75 kilometers. So you're trying to find, again, what I boxed there is what it is on the map. Well, on the map, again, it's going to be in centimeters. So it kind of gives me an idea of what my final units will be. So I do 1 over 75, and I said that equal to, I don't know, which again, unoriginal, I call it X a lot, over 1,200 kilometers. And then you cross multiply and solve and get 16. And so again, if the question is a sentence, your answer should also be a sentence. All right, now let's look at some properties of proportions that we really haven't covered yet. Okay, so let's look at this property number 3. If I have A over 10 equals C over 5, then A plus 10 over 10 equals C plus 5 over 10. Now, really what this is saying is this. If I have a proportion set up, which we do, we have this proportion here, A over 10 equals C over 5. So we're saying, hey, whatever's A and C are, this proportion is true, okay? So if you were to cross multiply, you'd get, 5 times A is going to equal 10 times C. Okay, so whatever number A and C are. Okay, so that's a true statement. So what they're saying is if we have a proportion that's a true statement, then you can take the denominator on each proportion and add it to the numerator. Now, I just used a little vocabulary with you. The denominator is the bottom number of a fraction, the numerator is the top number. So all they're saying here is that whatever numbers down here and here can be added up here, which is what we did over here and over here, can be added there, and the statement will still be true. It's not going to be the same as before, but it's still going to be a true statement. So we want to take that and roll that into what's going on in this practice. Okay, so if I have 3 over x equals 2 over y, then 3 plus x over x equals blank. Now, it will be a fraction here. Okay, so why don't you take a shot at what you think it should be? Pause it, and I'll give you the answer here in a moment. So you should have 2 plus y over y. Finish number 2. So for number 2, you should have 8 over 5 equals 9 over 7. Now here's the thing. Students will see, the property here, number 3, and they'll see number 1, and then they'll see, and they'll be like, okay, I got it. And we do one like number 2, and they're like, what in the world just happened? Well, let me show you what happened. Instead of writing it as 8, what if I wrote it as 3 plus 5 over 5? Now it's starting to look kind of like what we did here on practice number 1. And then instead of 9, what if I said 2 plus 7 over 7? And so then it's kind of looking like what we did with that 2 plus y over y. All right. Now, again, if you have like terms, you do need to combine them. So it's not acceptable to have your final answer be written as, 3 plus 5 over 5, because you need to actually simplify that. Okay, so combine your like terms. But it just to give you the idea of where we got that from. Go ahead and go and do these 8 questions. On questions 1 through 4, you were just filling in what goes in the question marks. And 5 through 8, you're telling if it's true or false. Now remember, to be a true statement, if you cross multiply, it should be the same thing. So when it says on number 5, if x over y equals 2 over 9, then y over x equals 9 over 2. If you cross multiply and they're still the same thing, then it's a true statement. If not, it's false. Okay, so just keep in mind things that we've talked about in here. So go ahead and pause it. Whoops, didn't mean that to happen. So go ahead and pause it, and then I'll show you the answers. Okay, so you can see your answers here. Notice how on number 3, I went ahead and I did combine the 5 and the 8 to get 13. Again, looking at 5 and 7, noticing that if you cross multiply, it's still 9 times x, regardless of which way you do it. It's still y times 2 or 2 times y, regardless of how it's written there, oriented. And then on 7, it's 9 and x and y and 2 still again. On 6 and 8, so 6 you should see when you cross multiply, you're no longer getting 9 times x. It's 9 times 2, and it's 2 times y on the left and x times y on the right. Anyway, as you cross multiply these. But number 8 is the one that's a little tricky. If they had written a -7 instead of just a 7 on there, that would have been actually a true statement, okay? Because you're subtracting the y on both. Anyway. So take a moment, fill in the missing work on this. So pause the video here, and then I'll show you the answer. Let's go ahead and take a moment to check your answers with what I've written. Again, noting on part B how you can subtract the b from the numerator like that. Okay, so now we're getting into actually what this section is about. So that was all review. Now this is the new stuff. Okay, so take a moment, pause this if you need to, write this down. But similar polygons, 2 polygons are similar polygons if their corresponding angles are congruent and the lengths of corresponding sides are all proportional. So we'll get into more what this means, but basically what you're saying is corresponding angles are congruent. Okay, so it fits that. And then all of the sides, when you compare them and write them as a ratio, so you take corresponding sides and write them as a fraction. When I say ratio, think fraction. Okay, so I take corresponding sides and write them as a ratio. When you simplify them all, they're all the exact same. All right, so they have to be proportional. And we'll see examples on what this means. See our similarity statement there, and this would be we can say polygon, but really it's 4 sides. So a quadrilateral ABCD is similar. Notice that little similar symbol there. It's similar to GHIJ. So it's kind of like the congruent symbol. Again, remember congruent means same size and shape. Similar means just the same shape. That's all it means. Okay, so not necessarily the same size. And then the statement of proportionality. That's basically, again, taking all of the similar sides or the corresponding sides, right, and writing them as ratios, or in other words, fractions. So statement of proportionality, you will be expected to be able to do this. So notice how they did, side AB, so that's this side over here. It can be divided by side GH, okay? And then they continued on, okay, comparing side to side. And I would note that they are consistent, okay? So AB was on the top in the numerator there. So BC would have to be, and CD would have to be an AD. So notice that they didn't try to flip it or anything there. Okay, so if we're given 2 figures and we're determining whether they are similar or not. So it says determine whether the figures are similar if they are, write a similarity statement. So remember, all the corresponding angles have to be marked congruent, which they are if we look. You got a single, double, triple, and quadruple marks. Okay, that's good. So what's helpful about this is with the angle markings like this is it's easy to tell which sides. Now, this picture, these 2 shapes aren't too bad because we can clearly see the sides are kind of oriented the same way. Like for instance, the 12 and the 9, we're going to be looking at them together, right? The 8 and the 6 together, the 16 and the 12. and then the 20 and the 15. So that's kind of what we're going to be comparing here. And there, sometimes shapes won't be oriented nicely, and so you're going to have to really be careful. So what we're going to do, okay, is you're going to check the sides are proportional. So we're just going to come down here, and I'm going to pause it so this goes quicker than me sitting here and writing it. But we're going to write out and then simplify. These should all simplify to be the same thing, or these shapes are not similar. So I've written down all the corresponding sides that we're looking at here. So FG is H, KL is 6, 8 over 6 turns into 4/3. And the same thing for GH and LM, and so on and so on. And you'll see that they all simplify to 4/3, so they all have the same scale factor. Okay, and so these shapes are similar, so the answer would be yes. Okay, so our similarity statement, again, we could go FGHJ is similar, and again, order is important. So if I start FGHJ, then it's KLMN. And then the statement of proportionality is literally writing basically all of these ratios set equal. So FG over KL is equal to GH over LM. Okay, I'll do that. I'm going to pause it and do it. So there's our statement of proportionality, how it's written out like that. Okay, again, this is vocabulary you need to be familiarizing yourself with. Okay, so similarity statement and statement of proportionality. So you should be writing this down as well. You've heard me mention scale factor, I already said it, but it's the ratio of corresponding measurements on the two figures. So looking at these two triangles here, hey, we're saying that they're similar here. That's what we're stating on here. And so we can see that if it tells us that, then we really only need to check two of the sides. Okay, now if we're trying to determine if they're similar or not, you have to check all the sides. But if they tell you that in a statement in the directions, then you only would check one of them to find the scale factor. And so you can see here inside here, they went ahead and they did BC and YZ, and they compared them to each other. When you simplify that, you get 5/2. So again, it's important to recognize that they're comparing large shape to small shape. You need to pay attention to this, because if for instance, it said, hey, what's the scale factor triangle ABC to triangle XYZ? Okay, so we did that. And you instead wrote it as, YZ over BC. So you wrote it like that. So you did 8 over 20. You're going to end up saying the scale factor is 2/5 or 2 to 5. Now remember, you can write that like this, and then it's going to be wrong because you have it backwards. So it's important you recognize they were comparing the big shape to the small shape. So when you find your scale factor, you better be getting a number that is an improper fraction, basically. So anyway. So now we're just going to practice, okay, whether determine the triangles are similar or not. If they are, we're going to write a similarity statement, write the scale factor of the smaller to larger. So again, notice it's saying smaller to larger. Please pay attention to this. Kids miss that part on tests all the time, and it's a dumb reason to lose like 0.5 point or something on tests. Anyway, so all corresponding angles are marked congruent. We can see that on the two pictures here. And so now we want to just start comparing, okay, sides that match. Now, what's nice about this question is they're oriented the same way. So I know that if they're going to be similar, okay, then it's going to be, for instance, MJ is going to have to match to WT. So I'm going to say 6 over 6, right? And we know that simplifies to 1. Now, again, immediately alarm bell should go off, because we could just check this very next side right here. Okay, this side's 12 and this side's 6 here. So I'm going to do 12 over 6. And I do want to point out that I did it the wrong way. I did larger to smaller, but either way, we're going to notice something wrong right away here. So 12 over 6 simplifies to 2 over 1, which these are not the same, and so it's already broken. So are these similar? No, they're not similar. By the way, if you're given like a test or a quiz and it's asking you multiple questions, like, hey, are these shapes similar? If you go, let's say, and get 6 questions and you say 5 of them or 4 of them are not similar, you're probably messing up somehow. So just obviously finding that they're not similar, kind of like, oh, hey, stop, your work's done. All right, let's go on to the next question. So again, on here, one thing that I think you're going to notice immediately when you're checking at this is hey, not all three sides, sorry, not all three angles are marked. Well, correct. But think back to last semester, the third angle congruence theorem states if I have two triangles with two angles congruent, then the third angle is forced to be congruent. And that's because those interior angles of a triangle have to add to 180. Like they have to. It's a rule. It's what has to happen. And so it forces that third angle to be congruent. So we're not broken yet. So now we want to start comparing side to side. So and now again, you got to be careful. It is saying smaller or larger, so I am going to try to be careful and monitor that here. But now what we're going to notice on here is that they are not oriented nicely. So I'm going to have to be mindful. So like, for instance, here's a single arc mark and here's a triple. So I want to find, so if I'm going to use that 15, and again, obviously that's the bigger triangle, right? So I want to go ahead and look now, okay, on the smaller triangle, where is there single to triple? Well, that's here to here. And so that's the 10. So 10 over 15, that becomes 2/3, taking a 5 out of both. So right now, if the next one I check doesn't have 2/3, then we can say not similar and be done. If it does, you still have to check the third side. You got to check all the sides always. Okay, and that was actually another way to think about that is we compared big to big, right? So, I mean, that's another way. You can look at the angles over the sides. And so I'm gonna be lazy, I guess, and say, okay, well, you compared big to big, let's compare small to small. So 9's the smallest there and 6 is the smallest here. So I'm gonna put 6 on top and 9 on bottom. Okay, you can take a 3 out, that's 2/3. Hey, oh, it looks like it's checking out so far. Okay, so now we're gonna check the very last one, and that is the 8 and the 12. So 8 over 12. 8 over 12. You can take a 4 out of both of those. So that becomes 2/3, and they all have the same scale factor. Okay, so write the similarity statement. And since we're wanting the scale factor smaller to larger, I'm going to go smaller to larger for this. So we'll go TVS is similar. So that, and I'm going to actually say it's a triangle. Triangle TVS is similar. Notice my notation. A lot of times people forget the triangle symbol after that. Please don't do that. Okay, so TVS, it went double arc mark to single arc mark. So I'm going to go QPR. So triangle QPR, and I'm running out of space there, but I made it fit. Okay, write the scale factor. So 2 to 3. Again, you could leave it as a fraction if you wanted. 2/3, that's fine. But there's that question. Let's look at the next one. Okay, so I'm going to kind of turn you loose on this one instead of walking you through it step by step. So again, notice that they were not kind. They are not oriented the same way. It does say smaller to larger, just like before. And I'll give you a little pro tip or whatever, a little hint to start. All the angles are marked, so we have that already. So now you're just checking the sides. So why don't you pause it right now, because I'm going to go ahead and write the workup. All right. So yeah, I went again. You can go by the angle marks or just say biggest to biggest, smallest to smallest, leftover to leftover. So 16 over 20, 8 over 10, 12 over 15. They are all 4/5. Hey, they all check. So these must be similar. So I wrote my similarity statement. Boom, right there. And then it asked me for the scale factor, smaller to larger. I wrote it 2 different ways. You don't have to write it both of these ways. Okay, you don't have to write it both of these ways. But I wrote it as a fraction 4/5 or 4 to 5 as with the semicolon there. So now you're going to try to find the missing side. It tells you in the directions. It says these are similar. These two pentagons are similar to each other. So you're finding the value of x. So that means if they're similar, then we know that corresponding pieces have the same scale factor. So for instance, DF, which is the side we know here, DF is right here, these two here. So that means it's going to be similar or have the same scale factor in relation to KL. So again, that's right over here. Again, you may have noticed this, that the shapes are kind of flipped and turned and seen that anyway. So I'm going to write 9 over 6 is equal to, well, CD is what I'm trying to find, right? And so I'm going to call that X. And then I'm assuming it's going to be this 2, but let's just double check. CD is the first 2 letters here, and JK is there. So it's X over 2. Now, a couple of things to kind of think about. When you solve for X, a question you can kind of ask yourself, should I expect, if these are similar, should I expect to find X to be bigger or smaller than 2? These are ways that you can kind of check to see if you did your work right. And as I look at this, I see that 9 is bigger than 6. So X better be bigger than 2. So if you solve for X and you get us a number smaller than 2, then you probably set your proportion up incorrectly. Remember, you could set it up different ways, okay? So anyway, cross multiply, it's going to end up being 6x is equal to 18. So x is 3, which is bigger than 2, so that makes sense. Found the value of x. Again, directions tell you that they're similar. Why don't you go ahead and find the value of x here? Set the proportion and solve. Pause it and I'll give you the answer. So I put 20 over 15 equals 8 over x. And then I went ahead and I thought to myself, okay, 20 is bigger than 15, so 8 better be bigger than x. So when I solve for x, it better be smaller than 8. I solve for x, x is 6. Answer makes sense. Moving on to the next one. So this one's a little harder because we have a shape inside of a shape. Now again, directions tell you that they're similar to each other. These two actually look like trapezoids to me. But anyway, so it's asking you to find both x and y. So again, you're going to actually have to find them individually. So like for instance, you're going to say, I'm going to find y, and then you're going to have to do a whole new problem and do x. So if I'm solving for y, I'm going to say, okay, what two sides do we know in both? Well, I see that side AD, this entire side here is 9, and I know that ED is 6. So I can put 9 over 6 and kind of work with that. Okay, so if I have 9 over 6, again, 9 is the length of the larger trapezoid. There's two of them there. So then I'm going to say, let's try to find y. Well, this side right here is going to be similar to that side there. So if I do the larger on top, 5 should be the larger of this, so 5 over y. And so then you cross multiply, 9y gives you 30 when you cross multiply. And what's going to happen when you're working with these is you're going to end up getting decimals at times, right? So 30 divided by 9, it gives me 3.3 repeating. So I'll just do a little repeating line on that, and that's the y. Solving for the x on here, again, you're going to still use the 9 over 6 because if they're similar, right, the directions tell you they're similar right over here. Right, that's what that symbol means there. Then your scale factor is going to be the same for all the sides, so you really only need to know 2 of the sides. And as long as you know one of the other sides, you can find the missing side. Again, it's the same thing as before. We know the larger, and we're trying to trying to find the smaller. Okay, you cross multiply. 6 times 7.5 is 45. This one's going to give you a nice answer. It's 9x is equal to 45. Ooh, 45. 4.5. Divide by 9 on both sides, right? You get 5 as your answer for x. So y is 3.3. Again, it's not uncommon to get decimals when you're working with proportions, and then x was 5. Okay, so your class is making a rectangular poster for a rally. The poster design is 6 inches high by 10 inches wide. Now, again, so that there's no distortion when you enlarge or shrink this, which is going to be enlarging here, okay, that it needs to basically stay the relationship for every 6 inches long, or sorry, every 6 inches, long it would be, then it's going to be 10 inches wide, okay? So anyway, all right, the space allowed for the poster is 48 inches high by 96 inches wide. What are the dimensions of the largest poster that fit the space? So you basically need to figure out which one's going to limit us. Is it going to be the height, how high it is, or is it going to be how wide it is? So we're going to look at that here. So at this point in the question, I went ahead and I drew the two shapes. So we had 6 high by 10 inches wide and 48 inches high by 46 inches wide. Now you're going to notice I made a proportion there, and it's 6 over 10 equals 48 over x. But what this is trying to show is this. We need to calculate an x value and a y value to determine which one of the dimensions are going to limit us. Again, so there's no distortion in our picture. Okay, you can only stretch or blow it up a certain way. So we're going to do 6 over 10 is equal to y over 96. Okay, so we're basically doing the how high it is, how wide it is in comparison to each other, and we're going to figure out which x or y is not going to be possible. So you're going to cross multiply and solve both values, and whichever one does not fit the limits that we have, then we know that's the one that it's going to be limited by. So we'll show you here in a moment. Okay, so I set up proportions and I solved. I got my x value to be 80 and my y value to be 57.6. Okay, what in the world does this mean? Well, it means this. If I go ahead and I make the height, how high it is, if I make it using the dimensions 6 by 10 here, okay, if I make it 48, then it's going to be 80 inches long, which fits in my 96-inch space. If I go ahead and I make this, again, 6 by 10 dimension here, if I blow it up to where how wide it is 96 inches, then the y value, how high it'll have to be, that value there, is going to be 57.6, which we don't have space for that. We have space to fit the 80 here on how wide it is, but we won't have space to 57.6, which means then we are going to be limited here by our how high it is. Our height is going to limit our shape. So after doing this math, then we know that we're limited by this 48. And so what are the dimensions of the largest poster that will fit in the space? It's the 48 and the 80, because these dimensions here, the 96 and the 57.6, they won't fit because you only have 48 inches there to fit it in. Okay, so what are the largest dimensions? They are 48, by 80, and my units are inches.